Hi everybody! In this video we will be talking about naming acids. Now we can't name acids if we don't even know what it is. That's just not right. So let's talk about what an acid is. An acid is any covalent compound, like HCl, that releases an H+ ion upon entering water. So for example, if HCl is originally a gas and it enters water, then it will become HCl in its aqueous form. And we use the aqueous to denote that it's in water. And once it enters water, it will split up into an H+ aqueous and a Cl- aqueous. Notice how minus and plus add up to 0. So the charges on each of these cancel out once you add them together. So H+ is always found in, a +1 form. And the Cl is always found in a -1 form, because in the last video we learned about how certain elements on the periodic table have certain charges, and this is one of the examples that uses that trend that we learned in the last video. So HCl and many other acids are called strong acids, as shown here. So here's a list of all the strong acids, and they're called strong acids because when they enter water, they will ionize into their respective ions almost 100% of the time. And why do I say ionize? Well, it's because when a molecule like HCl goes into water and turns into ions, you're transforming a neutral molecule or compound into ions, which means you are ionizing them. So that's a cool term. And what's the difference between ionizing and dissociating? Well, let's do a new chart. So if something like NaCl becomes Na+ and Cl- when dissolved in water, it is dissociating or separating because, think about it, Na+ and Cl- make up sodium chloride, and all that's happening is that they're just being separated, which is why this process is called dissociation. Meanwhile, when something like HCl ionizes into H+ and Cl- ions, it is transforming from a molecule, a covalent compound, into ions, and that is called ionization. So that's the difference between dissociation and ionization. So you should watch for that in the future. Now, let's talk about weak acids. Weak acids, unlike strong acids, do not ionize 100% of the time. Instead, only a fraction of the weak acid will ionize in water into F- and H+, for example. So in order to identify strong acids versus weak acids, you simply memorize all this as being the strong acids, and anything that's not on the list is usually a weak acid. And for our purposes, this will almost always occur. So for example, if you see acetic acid, that's not on this list, so it's a weak acid, because it does not ionize 100% of the time. Now, let's actually get to naming the acids. So, acids are kind of like salts. For example, if we have HCl, and don't forget the aqueous, since that tells us that it's an acid instead of, a molecule in the air, such as HCl gas. So, HCl, how do we know that it's a 1-to-1 ratio? Well, we know that Cl is -1, and we know that H is just H+, so the charges cancel out. Now, what if I said HSO4? How many H's do I need to balance out the SO4? Well, we know that sulfate is 2-, so we probably need 2+ here. So that's why we need 2 H's, because each H is 1+. So we need 2 pluses in order to counteract the 2 minuses. So that's how you balance hydrogens in acids. And let's not forget aqueous there. So now let's talk about the rules. If we have an anion that ends with an IDE, we will name it in the following fashion. It will be hydro blank acid. And what I mean by this, well, let's take HCl aqueous. If this is the anion, which is chloride, then we basically have to change the ide form to an ic form. So this will be called hydrochloric acid. Now let's take another example such as HCN. CN is CN minus or cyanide. So let me write that out after I erase this part. So this will be cyanide. And what do? Well, we have to change the ending of hydro. So instead of saying hydrochloric, since it's a cyanide, we're going to change the IDE to an IC. So this will be called hydrocyanic acid. Let's not forget the acid. The only thing that's changing is this part. So now that we've got the ide endings for the anions out of the way, let's try to name anions that end with something else. And let's not forget this is aqueous. So let's try naming acids that have anions that end with ite or ate. So usually things that end with an ite or ate only have an aqueous form, unlike things that end with an ide, which can have a gaseous form such as HCl gas. So things that end with an ite and ate generally only exist in acidic forms, while things that end with an ide exist in both an acidic form and in a gaseous form, for example. So now let's look at acids that have an ite for its anion. So I accidentally did an erase tool, but it's fine. So what if we had something like HNO2? What would its name be? Well, the format for naming acids that end with an ite or ate for an anion will be blank acid. So let me show you how that looks like. So NO2 is nitrite. And all we have to do is plug it in here, but change the ite to an is. So this ite will turn to an is, so I'm going to write that down here. So this will be called nitrous acid. Let's try one more example. What about HClO aqueous? What would we call this? Well, we know that ClO just stands for hypochlorite, so hypochlorite. And in order to name the acid, we basically plug this in here and we change the ite to an is. So let's do that. So it would be hypochlorous acid, and that's all. So let's talk about two exceptions, or two special cases. So anything that's related to sulfur or phosphorus will have a special type of naming. Although it's not far from what we just did, it is slightly different. So let's give you an example. So let's try to make an acid out of phosphite, PO3 3-. How many H's do we have to put in order to make this an acid? Well, we know that H plus is +1, so I'm assuming we need 3 H pluses. So our acid will be H3PO3 in its aqueous form. Now, let's try to figure out what this is called. So this is phosphite. So phosphite. And in order to name the acid, we just put acid, right? And in the blank, we plug this in, but we change the ending of an ite to an is. So will our acid be called phosphorus acid? Well, not exactly. You see, for things with phosphorus in it, we have to add something extra. So in between the H and the O, we have to add an OR. So, oh, that doesn't look like an R. Now it does. So let's change the name now. So knowing that fact, let's change it. So we have to add an OR and then OUS. So now it's phosphorus acid, and it sounds much better, and this is the proper way to do it, by adding that extra OR before is. Now what about something like H2SO3? SO3 2- is sulfite, so our acid will be called sulfus acid. It doesn't sound right, and that's because it's not right. In between F and O, aka before is, we have to add an UR. So let's change this knowing that. So instead of sulfus acid, we get sulfurous acid. So the difference is that we add the UR before is, just like how we added the OR before is for phosphorus acid. So now let's look at the 8s, because we've been only dealing with the ites. So we have 8s, then let me erase this bottom in order to show you one example. So let's try naming this HNO3 in its aqueous form, because acids are in their aqueous form. So let me see if I put aqueous for all of them. Oops, I didn't put it here. Gotta put it. It's very important. So let's go back. Oops, went too far back. I think this is it. HNO3. NO3 is nitrate. So this 8 will become an ick when you transform it into an acid. So this will be called blank acid, and the blank will be nitric acid, and that's what HNO3 is called. Now let's try another example. Let's try HClO3. This is chlorate. So in order to name the acid, don't forget the aqueous, this 8 will become an ick, and we will call it chloric acid. Alright, let's try to do the exceptions now with the P's and the S's. So for our P, I will choose, how about phosphate? So H3PO4. And it's 3 because this has a -3 charge and you need a +3 charge to cancel it out. So this would not be called phosphoric acid. Remember, we have to add the OR before the ick. So this would instead be called phosphoric acid. And that's the correct way to do it, and that's the wrong way to do it. Now let's look at the S. So for S, we'll choose sulfate, so H2SO4 in its aqueous form, and this is also in its aqueous form. So H2SO4 will be sulfate, so we have to change the 8 to an ick, and we have to add a UR here. So let's do that. So it will be sulfuric acid, and that's the correct answer. Let's try, with our knowledge, to name acids now. Let's try something like H2S2O3. And look at there, that's a thiosulfate. So in order to name this, we have to remember that anything with an S or a P will have, the UR or the OR added to it. So for this one right here, we will call it, since it ends with an 8, something acid. So let's think. We would call it thiosulfuric acid because we add the UR and the 8 becomes an ick. So that's one case where you would use that sulfur rule I taught you. So let's now do some practice questions. What would HIO aqueous be? Let me see if I put aqueous in the last one. Oh, I didn't. Better add aqueous. That is very important to do. So HIO, well, we know that IO minus is equal to, I think this is hypoiodite. So now let's try name the acid. So it would be hypoiodous acid. And that's the correct answer. Let's try something else. HC2H3O2 aqueous. Now immediately from this, you can see this, and that's acetate. So now let's use our ate to ic rule. So acetate would be acetic acid. Let me make that A more clear, and that's the correct answer. Let's try something like H2S, aqueous. This would be hydro. So why are we using hydro? Well, in the very first rule I taught you, if it ends with an ide, then you do hydro blank acid. So in this case, our anion here is S2-, which is sulfide. So we're using the ide rule, so we had to use hydro. So hydrosulfuric acid. And why did I add the UR? Well, remember, if it has an S or a P, we always have to do that. It's just something you get used to. Now let's try something a little bit more interesting. How about HCl in its gaseous form? Well, this would be hydrogen monochloride. And you might be asking why? Well, this is in its gaseous form, which means we are not using the rules we just learned for naming acids, since this is technically a covalent compound. So we had to use our rules from a few videos ago to name this. So this would be hydrogen monochloride. Now, what if I changed this gas and I made it aqueous? Well, since it's aqueous, it's now an acid. So let's name it as if it were an acid. So this would be hydro, of course, because this is chloride. And if it ends with an ide, we have to use the hydro blank acid rule. So chloride would be chloric, so chloric. So hydrochloric acid. Not so bad. Now let's do one last one. What if we had an acid containing chromate? What would the chemical formula be for the acid? So we know that chromate is CrO4 2-, and if you don't, you could either memorize it or pull up a table of polyatomic ions. So how many H's do we have to add to cancel out the 2- charge? Well, remember, in acids released H pluses. So you can think of an acid as kind of like a salt, but not really. But you can still think of it as a salt. So if this is 2- and this is H plus, we need two of them so that it's +2 -2, 0. So our, I guess, chemical formula for this acid would be H2CrO4. This would be called chromic acid because we changed the ate to an ic. And I think that's enough practice for now, so thank you for watching. Have a great day.